risk prediction and sentiment analysis. Our project is aimed to provide insights into the behavior of wildfires by conducting exploratory data analysis and predicting the cause and severity of these events based on environmental and geographical information. By doing this, we hope to be able to preemptively reduce the risk of future wildfires. What makes our project unique is that we apply multiple models to conduct the most accurate one and utilize the Twitter API to provide sentiment analysis based on disaster tweets in specific locations. This helps us to predict how people are reacting to the wildfire and allow us to better understand the impact of the event. The business value of this project is also significant. By being able to mitigate the damage caused by wildfires, we can reduce damage to property, corruption to the natural environment, and disruptions to operations. We can also implement fire prevention methods and additional protective measures in high-risk environments, such as clearing dry brush and implementing fire breaks.
Let me introduce the data part of our project. So the main data that we use is the wildfire occurrence data collected from the USDA Forest Services. So actually this data set is very large. It contains more than 2 million records of wildfires. For example, the dates of the fire and the size of the fire, etc. So this demonstrates the volume of our data set. And on top of that, we will also collect Twitter data with related wildfire-related hashtags and rank according to the number of retweets. And this can demonstrate the velocity of our dataset. And as I mentioned above, the wildfire dataset includes many features, such as fire size, latitude, longitude, discovery date, and the cause. So these different features demonstrate the variety of our datasets. So below is the raw data preview. This is the data frame that we will get, and we will train our models based on this. So here is some exploratory data analysis. So we can plot the frequency plot of fire cost, and we can see that the most often case is the missing data, and then followed by debris and open burning. So later on, we will group these different categories into small groups so that we can better predict them. And we can also look at the top 10 states with most wildfires. And here is the frequency plot after regrouping these categories is according to these 4 reasons. One is deliberate, the other is natural, and then other, and then accidental. Here is the geometric distribution of the wildfires. And this is the Twitter data that we will collect it. And this, like I mentioned above, we rank this Twitter by their retweet counts. So the methodology we use is some machine learning models. Just to remind that the goal of our project is to predict the cause of the wildfires. So it's basically a multi-class classification problem. The machine learning models we will use is random forest, logistic regression, support vector machine, gradient boosting tree. So we use these following features to predict the cause of the wildfires. So the data preprocessing steps basically are listed as below. So we first reduce the number of fire causes to 4 different categories. And then we do data standardization, which is a common step before machine learning. And then we can encoding the categorical data. And because there is a highly unbalanced nature within our datasets, so we will employ these SMOTE techniques to balance our data to better train our models. So this is my part.
So here is an overview of the system. For the front end, we use Plotly for data visualization and user interactions. For the Twitter workflow, the tweets are extracted from Twitter API and then saved to BigQuery and then sent to Data Studio for further analysis. And the dashboard for the final analysis is also presented on the website. For the machine learning workflow, the training data is saved in the cloud storage and then trained in compute engine in GCP. And the model files are saved and uploaded into the directory of the web application so that users can make predictions on the website. So here is an overview of the website. I will do a demo of the website. The first tab is a map of the wildfire. Here you can see how the fire developed throughout the years in the US. You can also select a year here to see a year-specific graph. And the second tab shows the number of fire by states. And then the next tab shows a breakdown of the cause of the fire. And then here's a prediction tab. So users can make predictions based on these inputs. And the final tab is the Twitter analysis. So the number of tweets are sorted by the tweets are sorted by the number of retweets here, and if any tweet has longitude and latitude coordinates, it will also be displayed on the map here. So this concludes our presentation. Thank you.